Alright, day 15. We get the input, which is a grid and a bunch of moves for the robot. The grid has a robot and it has a bunch of boxes, free space and walls. So if we get a left move, we need that means we want to move the robot left. We need to check if it can move to the left, and if it's a box, we need to check if that box can be moved left. And if both can be moved left, we will push them to the left. And so since we've done a lot of grid problems, I've copy-pasted some code from previous days. So we have a grid. We can create it from a list of characters. We can do find, set get, find all, and print it for debugging purposes. Also a function to map each of the move directions to a vec2. And notice that left means negative in y because this is the column and x is the row. So we start by reading the data. We need to get all of the lines. And then we need to split it on the empty lines, so we have all of these lines and all of these lines separately. Split it on line is empty. Then we want to create the mutable grid from the first lines. So iterate over them, map them, get the characters, and collect in the end. Then we want to the moves, and so they are split up on multiple lines, so we need to get a flat map them, so we get just one big list of all of the moves. And this is then at index 1, the moves. Iterate over them, flat map the line, characters, collect, and we need to say that we are collecting a list of characters. So then we have the grid and we have the moves, and then we can start solving this. So we will go through each move in the moves list. So iterate over that. And then we will try to move the robot. So we'll call that function try move robot and send in the move. And then I'll use sed to generate that. I'll create a new implementation of the grid where I add all of the gameplay code, and so then for next days I can just copy paste this again. First thing we need to do is get the direction from the move. And then we need to get the robot position, we'll call that pos. So that would be self find the robot position. We then need to check if we can move the robot in a direction, and if that is true, then we will move the robot. So we will do it in 2 parts. So if self, and this needs to be mutable because we're gonna mutate the grid, can push, and this needs to be unwrapped, position, direction, then we will push in the position direction. And so then I will generate these methods. So when can we push? So we need to get the position that we are moving to and then check if that is a box, if it's a free space, box or a wall. So let the next will be position plus direction, and then the next character will be self get next, and then we can unwrap that because the input, it's surrounded by walls, so we will never move outside of the grid. So then we can match next C. This will just be a panic. If it's a dot, it's true. If it's a wall, it's false. But the hard part, if it's a box, or actually this will never happen, so we'll just say otherwise. If it's a box, then we want to return self can push for the next and in direction. So recursively, if we want to move the robot left, we check here, can we move it left? Yes, yes, yes. And then we actually need to push it. So we can just copy paste this, and we know that this will never happen. So what we want to do is we want to set the next character to be the current character and the current character to be a dot. So self set, and this needs to be mutable, set next position to the current character, and the current character will be position. And then we need to set the current position. So self set position to dot. But if it's we just want to do that if it's true, but we also want to do it if it's a box. But first we need to actually push on the child. So we'll do that, and then we can just do if next character is not equal to free space, then we will push on the child. And this needs to happen afterwards. So then we moved all of the robots. We then need to find all of the boxes and get their GPS coordinates and sum all of their GPS coordinates. So let all boxes be grid find all O, and then the sum will be all boxes iterate map B for box the row times 100 plus the column, and then sum it. And so if we run this, and remove the placeholder, we get the correct result. Now for part 2, we're looking for this answer instead. The first thing we need to do is when we map these characters, we need to follow the new rules. So each wall becomes 2 walls, a box becomes a big box, free space, 2 space, and a robot becomes a robot, free space. So here we'll just do map, the character, match on the character, panic on that one. So wall should become a wall. Dot, and then we have also the boxes, and then we have the player. So player should become player free space. The dot becomes dot dot. The box become a big box. And then we need to change this to be a flat map instead, because now we return multiple values and want to flatten them. So now we have a big grid. Now we need to change the push and can push. So if we move, we now see that we need to change the logic when we hit the box. So if we are moving left or right, so in the row direction, in the Y direction in our grid, we need to move 2 steps over and check there. So if we get that we should move this one left, we need to check here if we can push it left. If we are moving in the column direction vertically, we then need to check if we can push the whole box. So if we are pushing on this one, if we are standing here and moving upwards, we need to check if this is free, but we also need to check if this is free. And then we need to push the whole box up here. So the can push, for the dots, it changes nothing. For the walls, it also changes nothing. But for this, it changes completely. So we now need to check if we are moving in the Y direction or in the X direction. So if we are moving vertically, then X will be not 0. Otherwise, we are moving horizontally. So we need to handle these separately. Horizontal is easy because we have the next, so that is position plus direction. So the next will just be next plus the direction. And so then we just return can push next direction instead of next direction. So very similarly. However, if we are pushing vertically, we need to check the both in the old way. So we can create two bools. So it will be, need to do it like before as well, but we also need to check if the left or right one can also be pushed. So if next character is equal to the open, then we need to call can push next direction, but we need to move this one over, one to the right. Otherwise, we are moving in the other direction. And so only if both these are true can we push. So that is the can push. The push is very similar. So if it's a dot, we should still do this, just like before. So we can call that else. But if it's a box, we need to copy this. So instead of can push, we are calling push. We already know that we can push, otherwise we will not be in this function. So we can remove all of this. And we now need, when we are pushing, if we are pushing horizontally, we need to make sure that we push both the next. So we need to move this character here and this character here, and yeah, this character here, but that is not part of this iteration. So we are pushing on this box. We need to first move this character here and then this character here. And here it's easy to make some stupid mistake. But let's try to not do that. So self set next. We need to set to what the value of next. right now is. Then we need to set the next to what the current character is. And then we need to set the current position to be free space. If we are moving vertically, there is no difference, so we can just copy paste this, because that is just moving one step like before, and we already know we can push it. We just need to make sure that we push on both. So if we run this, no, in the end we need to look for the big boxes instead. We get that one. Oh, I'm moving the... I need to map these characters. So I'm just moving the... And now, if I run it, we get the correct result. Alright, so yeah, a lot of grids. Probably gonna be more puzzles with grids. Pretty fun day, I think.